So perpendicular lines and planning a proof. So a couple vocab words for us here today. We have perpendicular lines. Have we heard of them before? I hope so. I hope so. It's a kind of a trick question. Yes, I have no doubt that we have heard of them before, but we're going to formally define them. If lines are perpendicular, then they intersect to form right angles or 90-degree angles, right? Because right angles are 90 degrees. So what should I see if I have perpendicular lines? What's that going to look like? Sebastian? Yep, they're definitely going to intersect, right? And they're going to form right angles. So what do I need to put at the intersection? Yeah, the right angle box. Good. So if I have perpendicular lines, they're going to look something like this. I'm going to have my two intersecting lines, and I'm going to have my right angle box in the corner. Okay. Now, how do I know if lines are perpendicular? Number one, you see the right angle box. That says, yes, these are perpendicular. Number two, it might be given in the directions, or maybe it's the given in a proof that you're doing. And what's that going to look like? Have you guys seen the symbol for perpendicular lines before? Julia, sorry. It is an upside down T. It's kind of nice because it just looks like perpendicular lines, right? So how this would look is if I wanted to tell you that two lines are perpendicular, you would say line AB is perpendicular to, you'd put your upside down T, and then maybe line CD. I'm just giving you two generic lines right now. But that's what you would see. The upside down T means perpendicular to. A couple other things about perpendicular lines. If one of these angles is a right angle, what else do we know? Ella? They're all right angles, right? The reason that happens is because isn't each one of these a little linear pair? So if one's 90, the other one next to it's 90. Also, your vertical angles are going to be congruent, right? So those are both 90, etc. Couple theorems. Perpendicular lines theorem. That says if two lines are perpendicular, then they form congruent adjacent angles. So if two lines are perpendicular, then they form congruent adjacent angles. All this is saying is actually basically what we just said, that if you have your perpendicular lines, won't all of your adjacent angles be 90 degrees? So they're all congruent. That's all that theorem is saying. Again, that should say lines, not linear. And then sometimes the converse is used. That says if two lines form congruent adjacent angles, then the lines are perpendicular. Those aren't used as often. It's just important, like in proofs, it's just important to realize that if one is a right angle, then the one next to it is a right angle, therefore they're congruent. Perpendicular pairs of angles. If two angles form a perpendicular pair, what that means is a pair, two right angles that the non-common sides are perpendicular. Okay. Then the angles are complementary. So this is actually an example of a perpendicular pair. There's two angles, right? That's the pair part. And the side they don't share, the rays they don't share, OA and OC, are perpendicular. Okay. So if that happens, then the angles are complementary. Now let's apply some logic to that. What does it mean if two angles are complementary? Mr. Kogel? Yeah, they're going to have a sum of 90 degrees. And if two angles, right, if we have our perpendicular lines here, if they're forming a perpendicular pair, won't you have a right angle? Our right angle is 90 degrees. Don't complementary angles add up to be 90 degrees? So are they going to be complementary? Yeah. We're going to write a proof about it. Okay. All right. So we are going to prove the perpendicular pair theorem. So we are given that ray OA is perpendicular to ray OC, and we are going to prove that angle AOB and angle BOC are complementary angles. So if we want to prove that they are complementary angles, we want to prove that they add to be 90 degrees. Okay, so sometimes if you're not sure where to start, that's a nice thing to think about is think, okay, where am I trying to end up? What does that mean? What am I going to have to say to make that happen? So let's put our first statement. We have ray OA is perpendicular to ray OC. That is our given. And when I provide you with a table like this, you kind of know how many steps are going to happen. Sometimes there's more than one good way to write a proof, and maybe you use more lines, maybe you use one less line or something. But just this kind of gives you some guidance, okay? So I'm also going to go ahead and put in my proof. That's a freebie. I know I want to end up at angle AOB and angle BOC being complementary. Okay, the question is, how are we going to get there? Well, something I mentioned in the first video where we did some proofs is to look for like context clues. Look for vocab. What do you know? Maybe you're trying to take one big segment, split it into smaller segments, things like that. Now, when we get into these, our context clues are going to be a little bit more vocab based. So if you look at your given, is there technically a vocab word in your given? Julia? Yeah, perpendicular lines. We have a vocab word. Perpendicular lines. It's written as a symbol, but it's still technically a vocab word, right? If I give you a vocab word, chances are you're going to need to use it. So I know I want to get to complementary. I know I'm probably going to have to say something about 90 degrees. So let's think logically here. How could perpendicular lines help me with that? What do we know about perpendicular lines? Ella? They intersect to form 90-degree angles, which are how many degrees? Or I said 90-degree angles. I was thinking I said right angles. They intersect to form 90-degree angles. Very good. So if I have perpendicular lines, am I going to have a right angle or a 90-degree angle? Yeah, let's say it. What angle is going to be 90 degrees specifically in our picture? AOC. So we're going to say that the measure of angle AOC equals 90 degrees. Well, how did I know that? What vocab word was I given? Perpendicular lines. So we applied the definition of perpendicular lines. And you guys are always welcome to abbreviate. I always like use a symbol instead of a word. You're welcome to do that if you want, or write it out if you prefer. Okay, so now I know that the measure of angle AOC is 90 degrees. But I need to end up with angle AOB and angle BOC. And have they been mentioned yet in my proof? No. So I got to figure out a way to mention them. Any ideas, Sebastian? Very good. That's taking us back kind of more towards the beginning of our chapter, right? With our angle addition postulate. We have a big angle. We want to talk about its parts. So we're going to show that angle AOC is made up of two smaller parts. Good. So I'm going to say that the measure of angle AOB plus the measure of angle BOC equals the measure of angle AOC. And that is the angle addition postulate. Good. All right, so again, I still got to get that the measure of angle AOB plus and the measure of angle BOC are 90 degrees, right? I got to show they're complementary. So how can I take the information I have now and go somewhere else with it, Matt? Very good. I can substitute 90 in place of measure of angle AOC. So let's do that. Measure of angle AOB plus the measure of angle BOC equals 90 degrees. And Matt said that is the substitution property. Excellent. And then we can see we're there, right? We have they add up to 90 degrees. That means they're complementary. What would be an appropriate reason, though? Julia? Very good. Definition of complementary angles. Good. Any questions about that one? Oh. Yeah. Yep. Okay, yeah, get it written down, Braden, okay? I'll give you a minute or two. Hey, and if you lose track, Braden, I'm gonna be uploading the filled in copy too, so you can always go back and look at it, okay? Okay, I'll leave it like this and we'll start the first two lines of the next one. I don't know if he's done copying that. All right, so we have that we are given that line X is perpendicular to line Y and line X is also perpendicular to line Z. We're going to prove that angle 1 is congruent to angle 2. This one's nice and short, right? So if you take a look, this one's actually only 4 steps. So let's go in, let's put our given. Line X is perpendicular to line Y, and line X is perpendicular to line Z. That is given. We are going to prove that angles 1 and 2 are congruent. So help me out. What can I do? You okay back there, Luke? Okay. Any ideas? Do I have a vocab word? Where can I start? Sebastian? Okay. So if I have perpendicular lines, what am I allowed to say? Okay, maybe I need to use the definition of perpendicular lines. Good. Which would let me say what about what angles? Matt? Very good. Now let's think. Why would that be helpful? Well, if they're both 90 degrees, are they going to have the same measure? And if they have the same measure, are we going to be able to say they're congruent? Is that basically the proof? Yeah. Do we just need to write it down all nicely now? Yeah. Okay. So let's say that. Let's say that we have those 90-degree angles. So we're going to say the measure of angle 1 equals 90 degrees, and the measure of angle 2 equals 90 degrees. And that is the definition of supplementary angles. Good. Now we can see here that both angles have a measure of 90 degrees. Where do you think I could go from here? People online are welcome to participate too. Julia? All right. Yeah, sorry. Someone online was about to say something and then Julia started. Yep. We're going to say the measure of angle 1 equals the measure of angle 2. And Julia said that is the substitution property. Is there another property that I would accept there? Substitution's good, but is there another one you could put too and it would still be okay? There's a property about how if two things equal the same thing, then they equal each other. Sebastian? Close. No. Julia? Not symmetric. Symmetric lets you flip them around. It's transitive. Yeah. Yeah, it would be transitive. So I would also accept that. If you prefer, again, whichever one is more easily recognizable to you. Anytime two things equal the same thing though, you can set them equal to each other using transitive property. You can also do that with congruency statements. So typically what tends to happen is we tend to use substitution with equations and transitive property with congruency statements. But technically, transitive property you could use with either. All right, good. So we're almost there. We have that they're equal. If they're equal, are we basically done now? Almost though, right? What do you think we could say, Sebastian? Yeah, very good. Definition of congruent angles. Good. Yep, that's what lets you kind of switch back and forth between equal and congruent easily. Julia? Oh, yeah, thank you. I wrote supplementary angles, didn't I? I don't know. That's not even 180 degrees. Thank you for pointing that out to me, Julia. Sometimes I write something silly at the end of the day. So yeah, so sorry about that. Perpendicular lines. So is his definition of perpendicular lines. We haven't even done something about supplementary yet today. Thank you. Yeah, if I ever write something weird down, don't just let me tell me. I'm a human. All right, we okay with those two? All right. So a couple different examples we have going on here in the diagram. Ray BE is perpendicular to ray AC, or this should technically be line AC. We'll fix that, line AC. And ray BD is perpendicular to ray BF. Find the measures of the angles to complete the table. So this is actually done in two parts. For the first part, I'm giving you that the measure of angle CBF is 40 degrees. And then for the second part of it, we're saying, okay, it's no longer 40 degrees. Well, what if it was just X? And you're going to rewrite them in terms of X. So first thing I would do here, guys, make sure you label your picture. BE is perpendicular to AC, so I would put your right angle there. And then you're also going to have ray BD is perpendicular to ray BF. Okay, I'd like you guys to take a couple minutes. Try to figure that out. The measure of angle CBF was 40 degrees. We wanted to find the measure of angle EBF. Who can tell me what that is and tell me how you found it? Ella. Yeah, very good. You know that the full thing's going to be 90 degrees, right? So you subtracted, right? Yeah, you would subtract 90 minus 40 and get 50. Good. So that's there. Angle DBE. Angle DBE. Mr. Boswell. Mm-hmm. Yeah. Yeah, very good. We already knew that angle EBF was 50 degrees, right? And we had another right angle here. So yeah, if you just subtract again, good. 90 minus 50 would give us that this one is 40. Angle DBA. Somebody else, what did you say for DBA? Julia? 50. How did you get 50, Julia? Good. Yeah. We had a right angle here with EBA. EBD is 40. Subtract that, you should get 50. Good. And then the measure of angle DBC. Measure of angle DBC. Luke, how'd you get 130, Luke? Yep, add up all your parts. It's made up of 40 degree, 50 degree, and another 40 degree angle. Looks good. Then for X, you kind of want to go back and use that same process, but this time we don't know what the angle is. We're just calling it X. We don't know what its value is though. So if I have no idea what angle BFC is, I just call it X, but I know I have a right angle. What could I say the measure of angle EBF is? Ella? Exactly, 90 minus x, because that's how you found 50 before, right? That's kind of the point of doing it with numbers first. You subtracted, so again, we would subtract. Good, EB or DBE, what could we call the measure of angle DBE? Sebastian? Not 90 minus x, you're overcomplicated, you're thinking too hard. You're thinking too hard. If you look at this one, wasn't angle DBE 40? And wasn't the other one 40? Weren't they the same? So if your first one's x, what can we call the measure of angle DBE? Help him out, Julia. It's just x, right? Because it's just the same as that original one, right? You don't have to subtract again because it would be the same. Does that make sense? Okay. Then the measure of angle DBA. Measure of angle DBA, what can we call that one? Julia? Yeah, that one again is 90 minus x. Good. And then the last one, 130. It was 130 before. So what could we do with it now? What could we say? Good. 90 plus x. Someone online said that. Looks good. 90 plus x is absolutely correct because with this one we had our right angle, right? And then we added our value that's equivalent to x to it. Very good. Questions, concerns? Okay. So now we got a true false one. It says that line AB is perpendicular to line CD. Use the diagram to classify each statement as true or false. So anytime you're given something like this, please make sure you label your diagram. So line AB is perpendicular to line CD. I'm going to put that on this side since the G is on the other side. And now we just got to go through and determine what is true and what is false. So first one, line or segment AB is perpendicular to segment EF. True or false? Yeah, that is absolutely false because those are not marked as being 90 degrees. We just can't be sure. Good. Angle CGB is a right angle. Is angle CGB a right angle? Ella? That is absolutely true. I'm confused though. My right angle symbol wasn't there. How are you sure? Right, absolutely. That's still formed by those two perpendicular lines. So all four of those will be right angles. Very good. Angle CGA is a right angle. I see Sebastian nodding his head over there. Yes, this is true. Yeah, this one's absolutely true for the same reason the other one was true, right? Because those are still formed by those perpendicular lines. Angle D. This should say angle. Here, fix this real quick. Angle DGB. Angle DGB is 90 degrees. Is that true or false? True. That is absolutely true because we have perpendicular lines. Perpendicular lines make right angles, which are 90 degrees. Good. Angle ECG and so EGC and EGA are complements. True or false? True. How can you tell? Yeah. Yeah, very good. So these two angles, if you combine them, they're going to make this larger right angle there, right? And right angles are 90 degrees, complements are 90 degrees. And then last one, angle DGF is complementary to angle DGA. True or false? Angle DGF is complementary to angle DGA. Matt? That is absolutely false. How can you tell, Matt? Very good. Yeah, DGA is already 90 degrees. If you add something else to it, right, that's going to be more. Very good. All right. Any questions about that so far? Feel pretty good about perpendicular lines? Cool. If I ask you to draw a perpendicular line, what do I expect to see in the picture? Yes, very good. I need to see the intersecting lines or rays or segments, whatever the directions state. I have to see that right angle box, okay? If I don't, then I just don't know if they're perpendicular. All right, so now we have 2 more theorems and then just a proof, and then we're gonna, I think I am gonna cut back on that homework a little bit. We're gonna work on that, and then we're done. You should have plenty of time on your homework today during class, so you can ask questions and stuff. So 2.6 theorems. There wasn't that much that was new in 2.6. It's more discussing how we should plan our proofs. Okay, there's 2 new theorems, but we've talked about supplementary and complementary before, so this shouldn't be too foreign. The supplementary angle theorem says if 2 angles are supplements of congruent angles or the same angle, then the 2 angles are congruent. So what that is saying basically is that if you have, and I'm just going to draw like a small example. Let's say I told you that angle A was 50 degrees, right? And I told you that angle B was 130 degrees. Those would be supplements of each other, right? Okay. Well, let's say I also had angle C, and I told you that angle A was congruent to angle C. What this theorem is saying is that if angle A is congruent to angle C, then angle C would also be a supplement to angle B. Okay. If 2 angles are supplements of congruent angles, or the same angle, or well, I guess actually the other way around. Technically, you can think of it this way if you want. I guess technically what it's saying though is if 2 angles are supplements. So if you knew that angle A was a supplement of angle B, and we knew angle C was also a supplement, so let's say we also knew that was 50 degrees, right? 50 is going to be equivalent to 50, so angles A and C are still congruent. So that's what that's saying, and just like a quick little picture example. Then complementary angle theorem, same idea, just with complements. If 2 angles are complements of congruent angles or the same angle, then the 2 angles are congruent. Okay, because they're all going to have to add up to be 90. So that's why that happens. So we're actually going to prove the supplementary angle theorem here. So this is saying angles 1 and 2 are supplementary. 1 and 2 are supplementary. 3 and 4 are supplementary. Angle 2 is congruent to angle 4, and we're going to do our prove that angle 1 is congruent to angle 3. Now, a couple things, because chapter or 2.6 is all about planning your proof. A couple things I want to mention before we dive into this one. First of all, your proof is made up of a couple different parts, right? And I feel like we're recognizing those. We have our given, our proof, there's often a diagram, and then it's a series of statements and reasons. I think we have that part down. If you're not given a diagram, please draw one. It's going to really help you, okay? So that's my one hint for you. Another hint for you, which I've been stressing, is to use your context clues. If you're given a vocab word, you will likely have to apply that vocab word and use your vocab sheet. I also recommend planning your proof before you start, right? Look at it, look at your picture, see what you know. Don't just like try to run through it. Look at it and try to make some sense of it before you start writing things down. And then my next recommendation is if you look at something and you're totally stuck, then try to work backwards. Look at your proof and see, okay, well, what do I need to say in order to make that happen? Like, remember in the other proof where I was like, okay, we got to show these are complements. That means we need to show they add up to 90 degrees, right? That was us kind of starting to work backwards, thinking, where do we need to get to? So sometimes those are helpful things. So if we look at this, again, use your context clues. Let's just look at our picture. 1 and 2 are supplementary. That means they're going to add to be what? 180. Thank you. All right. 3 and 4 are supplementary. That means they're going to add to be 180. But 2 and 4 are congruent. So let's say you randomly, just to help your brain out a little bit, pick a measurement for it. What do you want to say angle 2 is? We're not making a big commitment here. I'm just, sure, I like it. So 40, okay. Let's say I told you angle 2 is 40 degrees. What's angle 4 going to be? 40 degrees. This is just to help our brains plan our proof. So then what's angle 1 going to be? 140, okay. And then if angle 4 is 40 degrees, what's angle 3 going to be? 140. Is 140 equivalent to 140? So would they have to be congruent? Absolutely. And that's actually basically what we're going to do, except with the names instead of like 40. Okay. So let's first put in our statement. Our first statement is our given. So angle 1 and angle 2 are supplementary, and I am going to abbreviate this because writing in this little tiny box is hard when you're writing with a stylus. And then angle 3 and angle 4 are supplementary. And we're given angle 2 is congruent to angle 4. That is given to us. We want to prove that angle 2 is congruent, or angle 1 is congruent to angle 3. So use your context clues. What's your first context clue? I already mentioned it. First clue in your given, what is it? Matt? There's a vocab word. Yep, your vocab word is supplementary, so let's use it. How would I apply the definition of supplementary angles here? Like, what would I expect to see next? Any ideas, Sebastian? So the supplementary angle theorem is actually what we're trying to prove. Yeah, so once we prove it, but you're right. If you saw this, then like later, you'd be like, supplementary angle theorem is why, and you'd be done. But we're trying to prove why it works right now. So think about your definition of supplementary angles. Where could I go next? What should I write, Ella? Very good. Yeah, if they're supplementary, they're going to have a sum of 180, which means show me that in an equation, right? Good. So let's write that. The measure of angle 1 plus the measure of angle 2 equals 180. And then since it's the same reason, I'm going to do angle 3 and 4 in the same line. If you're writing this on your own and you don't want to put it in the same line, you don't have to. But anytime you have two steps and they use the same reason, you can combine them if you want. So I'm also going to put the measure of angle 3 plus the measure of angle 4 equals 180. And that was from our vocab word, so the definition of supplementary angles. Okay. Great. Now we know we need to get angle 1 being congruent to angle 3, right? They're in separate equations right now. Help me out. What should we do? Julia? Soon, but not quite yet, but we will do that in this proof. We will subtract. Matt? Absolutely. We are going to set these measurements equal to each other. The measure of angle 1 plus the measure of angle 2 equals the measure of angle 3 plus the measure of angle 4. And how did you know we were able to do that, Matt? Very good. Yep, they both equal to 180. Therefore, we can set them equal to each other. And what would be an appropriate reason? The transitive property would definitely be appropriate. Could you also say substitution here if you preferred? Sure, whichever one, again, is more logical to you. I have a tendency when they both equal the same thing to use transitive. That's what my brain goes to. Okay, good. So now, Julia, what can we do? Now we can subtract because they're set equal to each other. I know that, oh, soon, actually, still, I deceived you. We're so close still to doing that. We will do that, I promise. I can't quite yet, though. Does anyone know why? It's so tempting to do that next. You're like, 2 is here, 4 is here, they're congruent. I want to subtract them. But I have a bit of a notation issue happening. They're not quite ready to be subtracted. Take a look at how it's presented to you in your given. What symbols used? Yeah, so what we need to do is we're given that they're congruent. If they're congruent, will they have the same measure? Yes. However, we need to switch from congruent to equal first. Because technically, doesn't our subtraction property say that if they're equal, we can subtract them from either side? And right now they're not written as equal, they're written as congruent. So we need to fix that notation first. We can't, you can't, when things are like congruent and equal can be switched between, but it's a definition. So what we're gonna do is we're going to take the angle 2 is congruent to angle 4, and we're going to fix this, and we're going to turn it into the measure of angle 2 equals the measure of angle 4. And again, the reason we had to do that is because the subtraction property is a property of equality, right? Not congruence. And up here, they were written as congruent. So in order to apply a equality property, we have to convert that. Very good. And what reason would that be? Definition lets me do that. Julia? Yes, definition of congruent angles. Good. Definition of congruent angles. Good. And now they're ready to be subtracted. Because angle 2 is equivalent to angle 4. They're being added to the left and right. So we can subtract those out. And the measure of angle 1 equals the measure of angle 3 by the subtraction property. And then same idea as before. We're so close to being done. But look at our notation, right? We have that they're equal, but we need to show that they are congruent. Can I fix that? Yep, I can say if the measurements are equal, then I can say angle 1 is congruent to angle 3. What definition? Oh no, that's what we're proving. But how do I get from my second to last to my last step? Definition of congruent angles. Good. Good. And now we have proved the supplementary angle theorem, and you can use that in your proofs. And you don't have to do it. I think one of the homework problems is to prove the complementary angle theorem, though, so it'll be kind of similar. You should look at that. Okay, so that is all for notes.